Hello, everyone. I'm going to start a little early because I expect to run over a few minutes. So, anyways, my name is Ram Madhavan, and I'm from the developer support group of Sony PlayStation. And this talk should provide you an overview of the PlayStation VR specs, features, and discuss how PS4 provides you with like a solid platform, not only to develop a awesome VR experience, but also to become successful. So here's a quick snapshot of the content we'll cover today. We'll start by looking at the PlayStation VR specs, including some improvements that we recently added. We'll then talk about some unique advantages that PlayStation platform provides when compared to other VR platforms. We'll also look at some of the technology advantage that PlayStation provides, and also how it helps address some of the key issues and challenges faced by the current VR developers. So we'll then see how to get started with Unity 5.2 for VR development, and finally we go over the process of getting signed up and getting on board. So first up, the specs. So PlayStation VR headset has come a long way since we announced in GDC as Project Morpheus. So to start with, the headset has a wide field of view of approximately 100 degrees, and the display is made up of 5.7-inch custom OLED screen with a resolution of 1920 by 1080 RGB. So it is capable of up to 120 Hz refresh rate. So tracking has been improved significantly since we released our previous hardware revisions, and we have a total of 9 LEDs. That is 7 in the front, 2 in the back, and that gives a good 360 degrees coverage. Also, the LED information will be fused with other motion sensors to provide a much more accurate tracking of the head. We are also currently improving our overall system latency. We are already down to 18 milliseconds, and we are not done yet. I'm sure there will be more improvement as we get closer to the launch. PlayStation VR also supports 3D binaural audio that enables even more immersive virtual reality experience for players. And it doesn't need any special headphones or anything. It's just can be experienced with the regular headphones. And the best part is this is built in, and it's very easy to integrate into your existing games. One of the key differentiating features of PlayStation VR is the social screen that enables the VR content to be output both to the VR headset as well as the TV. And this feature enables non-VR players to see what the VR players are experiencing. And also another recently included feature is a separate screen mode, not just what the VR players are seeing, but also actually an alternate view of the game itself so that the non-VR player could participate and affect what the VR player is experiencing. So it's a really cool feature and makes for a fun experience for everyone else. Technologies aside, just like any other Sony product, user comfort is definitely in mind when we design products. So the headset is designed with longer duration of gameplay in mind, and also we've made sure that it's easy to wear and adjust, and even for people who wear glasses. So if you haven't tried it before, I highly recommend that you go check out some of the Morpheus demos in the PlayStation booth. So now let's take a look at some of the advantages of developing your VR game on the PlayStation platform. So first of all, PlayStation has been out for almost 2 years now. It's a fixed platform spec, well understood by game developers. And we also have an established controller interface in the form of DualShock 4, PlayStation Move, and also it can be easily tracked with the PlayStation camera along with the VR headset itself. And on the business side of things, we have a strong install base of 200 million PS4s, and it's global and counting. And not only that, but PlayStation has a strong consumer product strength and retail brand with established and thriving content marketplace, especially for games. And of course, we value relationship with developers, and we very much strive to provide you with the best possible tools and best hardware so that you can build amazing experience for the PlayStation audience. So to sum it up, you have an awesome, powerful gaming console in market with established specs, great tools. And then we have DualShock 4, PlayStation Move, and the camera, which are also in market. and add to that a state-of-the-art VR headset with awesome specs and just works with the rest of the PlayStation ecosystem. So all you have to do is sign up and build some awesome experience. So now let's take a look at the technology advantages and features of PlayStation VR. So before we get into the advantages itself, I'd like to start by calling out some of the challenges, technical challenges faced by current VR developers, starting with latency, so which is basically the time between a user action and seeing that effect in the game. So obviously, a high latency is bad for VR. At best, it can cause an eye strain, and at worst, it can cause disorientation or nausea to the player, which is certainly not good. So achieving a low latency is key. Accomplishing a high frame rate is also crucial. So, rendering at a consistent, 30 hertz or 60 hertz, which is acceptable for normal games, is not an option anymore. It will cause discomfort to the users. Ideally, you'd want to render at 120 hertz, but that means you just have about 8 milliseconds to squeeze your entire render frame, so which, of course, is going to be challenging depending on your game style, and it's going to be challenging for ambitious game content. And also just want to note that you're talking about stereo rendering here and not the normal rendering, so it's going to be much more higher. So how do we address these challenges? So I want to start talking about reprojection, but before that, I just want to do a quick poll on how many of you know what reprojection is? Just want to get an idea. All right, I would say about 30 to 40%. Okay, good. I'm going to take it slow. So the process of reprojection has been used in graphics for many years and to address different problems. So basically, what you do is you're able to render your game at 1 frame rate, and you're able to scan out at another frame rate, and usually higher. And basically, if you wanted to walk through the process of reprojection, would be as follows. First, you would sample the sensor data before the rendering starts, and then you would render the frame as usual. And then just before scanning out, you sample the sensor data once again and adjust your frame according to the movement of the head to compensate for the whatever little movement it is. And this kind of reduces kind of the perceived latency. So that's pretty much what reprojection is. So the green box here is kind of what the user sees. And so why is reprojection relevant? First of all, reprojection helps reduce the perceived latency due to the sensor data lag and also increases the perceived frame rate. And in PlayStation VR, reprojection is added at the system level using a lightweight async compute shader that runs on the PS4 GPU. It should only take a small amount of GPU work to do that process, so it shouldn't really have a big impact on your game, per se. And as mentioned before, reprojection is a well-researched topic, and the issues and challenges are well known, and also the solutions. To give an example, let's say in a VR environment, the user makes rapid head movements, and so as a result, reprojection could introduce some of the visual glitches towards, say, the peripheral side. However, there are known solutions for these issues to either eliminate or, mitigate the issues. So, well, the point here I'm trying to make is the advantages of reprojection greatly outweighs some of the disadvantage. So almost always use reprojection. So let's dive a little deeper here and compare contrast some of the rendering configurations. First up, let's say your game renders and scans out to the monitor at 60 hertz. As you can see here, the CPU task here is the blue, and then GPU is orange, and then we have a VR tracker, which tracks the LEDs. That's also runs on the GPU. So your game has about 16.6 milliseconds to complete the rendering. In this configuration, screen persistence, which is basically the length of time the pixel is on screen, that has a big effect on the user experience. For example, high persistent, in this case, can cause blurring or smearing in the screen, and whereas the low persistence, which is talking about less than 2 milliseconds, 2 to 3 milliseconds, could cause a noticeable flicker at low FPS. And by low FPS, I mean 60 frames per second. So basically, rendering and scanning out your game at 60 is just not an option. And the next case, let's say your game renders and scans out at 120 hertz. As you can see here, the game only has about 8.3 milliseconds to finish up your entire work, which is not a lot of time. But again, if your game's visuals are not super complex, then depending on your game's design, this might work. The latency here is certainly better than previous case. And also, the number of object movement artifacts introduced by fast-moving objects is less here. So definitely an upgrade from a last case. Now, in this case, your game renders at 120 hertz and reprojects at 120 hertz as well. So this is your perfect situation with the lowest possible latency. But as you can see here on the last line, we included like another little task. So there's like a slightly higher GPU cost as a result of the reprojection. So here, the reprojection is happening at 120 hertz as well. So at the end of each frame, the game just needs to supply the updated sensor data patch to account for head movement and between the start and the up until that point. So here, as you can see, the game is only has about 7.8 milliseconds, deducting the reprojection cost, again, which is not much. Similar to the last case, great, probably good for lightweight visual VR content, and maybe work for extremely fast Twitch content or even non-gaming VR apps. So obviously, 120 hertz is not possible for all games. So here's a case that offers the best compromise for both the high frame time and low latency. So as you can see here, the game renders at 60 hertz and reprojects at 120 hertz. So the reprojection job would take the previous frame's output whenever the current frame's output is not available, and then take the updated sensor data and again shift the pixel to consider the head movement. So this should feel very close to the native 120, and as I mentioned, it's a best compromise between the amount of time you have, which is 16 frames per second, and the low latency. So quick recap of the various options you have. Once again, rendering and scanning at 60 hertz is just not an option. It will cause discomfort to the player. So at least try for 90 hertz, and if only 60 hertz is possible, reprojection is required. Among the listed configuration, I think we reviewed the first three in the last three slides. And so similarly, 90 hertz native and also with reprojection are options if you can reach 90 hertz. So let's look at a big picture. So there's really not a one fix or silver bullet to address the overall latency, but a number of small improvements at various stages, both at the system level as well as at the game. Helps reduce the overall latency. So if you look at the PS4 and PlayStation VR combo, we start all the way from the head movement. We have high-speed sensor data from the VR headset, and then we have high-speed input devices, PlayStation input devices. And following that, the game's utilization of, say, the PS4 async compute queues to utilize the PS4 GPU to max. Then there are a variety of latency prediction techniques that your game could use. For example, the head movement is constrained, so the game could use techniques to predict where the head could be by the time the frame is presented. And then we have the reprojection techniques that is supported by the system that helps further reduce the apparent latency alongside the 120 hertz PS4 output. And also, the PlayStation VR comes with an external processing unit, or we call it PU. So that is a companion of the PS4 and does a lot of heavy lifting work for the VR itself. So we've made it much more powerful and are improving as we go towards the launch. So that should definitely lower the overall latency as well. And finally, a low persistent OLED screen should help minimize the screen effects like blurs, smears, and whatnot. So we talked quite a bit about latency. Now let's talk about improvements in other areas, starting with optics. So firstly, we have tried to exploit how the human vision works. Our eyes actually only see the details in the center of the vision. And if you look somewhere else, you notice that we naturally tend to move our neck and head instead of rolling the eyeball. So we've tried to exploit that. And for that reason, we have a higher concentration of pixels in the center of the screen, higher concentration of smaller pixels in the center, and then larger pixels towards the edges. So by doing this, we actually match the human visual system much more closely. Another important factor in immersing a player in the VR world is controls. So in VR, players naturally tend to interact with the VR environment just like in the real world. And PlayStation enables rich experience with motion controllers through like DualShock 4, PlayStation Move, etc. Now, not only these PlayStation controls are great for end users, but it's also it provides a good sandbox wherein you can experiment and try out different ways to provide VR controls. So because it's a complete ecosystem, this provides you an opportunity to experiment further. Another important aspects are the contact points that helps replicate the real-world interactions experience. For example, peripherals such as steering wheel, which already supports PlayStation 4, can greatly enhance the VR experience since their contact points almost matches with the real world, and the user would almost forget that they are in the VR world. Another example is the PlayStation Move's form factor, which is really, it can map to a number of different objects in the real world. For example, it could easily turn into a sword or a torch or even a hand for that matter. So they are fantastic. Also, with the recent SDK and system updates, in addition to improving the tracking itself, we've also unified all the tracking support, all the tracking devices. So basically, multiple tracking devices could now be tracked in the same coordinate space in any combination, and that is going to be very efficient. Moving on to the next feature, which is actually one of my favorite, is the social screen. So unlike many other VR solutions out there, much of it will restrict the player to a corner of the room. So PlayStation works with the PS4, which is usually like a centerpiece entertainment unit of the living room. And also when one player is experiencing, there's other players around them, family, friends, and whatnot, and they also want to be part of this experience. So with social screen, we have a mirroring mode, which basically means that the players around you can see what the VR player is experiencing, not just two stereo images, but actual screen. And also, there is a separate screen mode where a different view of the game could be rendered. And that kind of provides a maximum engagement to everyone around you. So here's a sneak peek of the game Monster Escape, developed by Japan Studios, where VR player controls the monster with the head, while the 4 other players could join in with the DualShock 4, throwing projectiles and defeat the monster. So as you can see, it could be in one couch, one player playing the headset, and all 4 could just have like a different view and interact, not just passive viewing. So I can definitely imagine a lot of unique situations coming into play. 3D audio is another very important component of VR and adds a new dimension to the VR experience. Having great sound really sets and creates mood for the player, and PlayStation comes with built-in support for 3D binaural audio with high degree of fidelity. It basically synthesizes with the advanced simulation how the sound enters the human ear. Basically, individual audio sources will now have position and orientation in the world, and as the player's head moves, the sound also moves. So it's a great experience if you haven't tried it before. Also, with the improved SDK, we now support a number of virtual speakers, and also we have improved the spatial accuracy of the height of the speakers as well. And the good news is, much of this heavy lifting is done by the external processing unit, and there is no real software or games impact. So just wanted to talk a little bit about Unity and PlayStation. So Unity and PlayStation have been partners since 2013, and some amazing games have already come out. And with full support to PlayStation VR, I think I cannot personally wait to see all the amazing VR content that's going to be on PlayStation. Let's do a quick overview of the current support for Unity on PlayStation. So Unity 5.2 supports all the 3 platforms, and it comes with fully integrated support for PlayStation VR, just like other VR platforms. So it should be fairly easy for you to bring the content from other platforms to PlayStation if you already are working on it. Also, the awesome part is Unity is free for registered PlayStation users, and the Unity version is Unity Pro. So whether you have it before or not, if you want to develop and publish on PlayStation, you get Unity Pro for free. And once you register to become a PlayStation developer, you get access to a developer portal called PlayStation DevNet, where you can download Unity 5.2 and also the plugins. So here's a quick rundown on Unity's PlayStation platform feature support. So DualShock 4 is fully supported, including audio, touchpad, vibration, motion control, light bars, etc. And similarly, PlayStation Move and full stereo camera and depth support for PlayStation camera is supported. 3D positional audio will also be supported fully, I guess. And as soon as we have the social screen update via the SDK, I think that will be added as well. And the rest is something that we already have, which is full compute shader support, full script debugging with Visual Studio, and also we have there's a plugin for NP Toolkit, which basically wraps all the PlayStation Network online features like leaderboards, friends, commerce, matchmaking, and whatnot. So it comes with full source code, so you can change whatever you want. And finally, speech recognition is also supported with headset and also camera on the microphone on the camera. So here's a look at the interface inside the Unity editor for Morpheus setup. Similar to other platforms, you just have to check the virtual reality supported box. And then under the resolution and presentation, you can choose one of those specified resolution and refresh rate. The first part is the resolution, 1920 by 1080, and the second half are the refresh rates. Once you're done with that, you have enabled reprojection support. I believe for 60 hertz, it's selected by default. So that means if you're doing it 60, then you will have to reproject. And for everything else, you can either select or not. And for audio, it's very simple. You can just choose the audio out 3D for the audio backend and pick the number of speakers you want in your game. And it's super easy to do it on the enable PlayStation VR on the script as well. All you have to do is assign VR device.type Morpheus to VR settings.loaded device, and you don't have to worry about the code snippet. It should come with a bare bones sample to which you can refer to later. Registering controller is also very easy now. I mean, you don't have to do it through different PlayStation 4 native plugins for different devices, but now all of them could be done registered just with the VR.tracker interface. And as I mentioned before, everything is unified and it should yield better performance. Unity documentation should be your first stop if you're starting for PlayStation development using Unity. So just go to the help and then the manual. Under the platform specific section, choose the PS4. And there you can see the getting started information for the platform, and also towards the end you will have the PlayStation VR related docs. And also there is PlayStation SDK, which has tons of awesome samples and documentation. If you're getting started, I would highly recommend you to take a look at that. PlayStation DevNet portal has like a thriving community of Unity developers. So there's a forum in which support is provided. So feel free to jump in and contribute. And also feel free to open up a private support ticket whenever you need. PlayStation developer support will come in and help whenever it's required. And also, if you find any issues with the Unity itself, feel free to submit bugs with reproduction projects, and They are private, tracked, and you'll get feedback directly from Unity. So assuming you're extremely convinced to develop for PlayStation VR, let's see how you get started. So what's important for PlayStation? Well, first of all, games that offer the user a sense of presence inside your VR world, and the games that are polished and feels like existing next-gen display or experience. And that doesn't mean only AAA experiences, but by polish, we actually mean more consideration to game design to make sure the player doesn't experience discomfort, and so on. On the performance side, I think I've made it very clear that 60 hertz with reprojected to 120 is something that we're looking for as a bare minimum, and 1080p with attention to detail. One more thing that is important to us is IDS built for the VR platform instead of straight up porting off the existing games. Because ultimately, what we want is, awesome experience for VR. Here's a quick rundown on the process. It's pretty straightforward. Sign up at playstation.com/develop, and once you fill the form, you'll be assigned an account manager. After that, you can request for hardware, register a prototype project concept, and then you're good to go. And the most important part is stay in touch with us. Stay in touch with your account managers. We'll keep you up to date on the development. And also, if you're interested in knowing about just the common processes, policies, and practice-related submission, then attend Peter Pickett's session about getting your game on PlayStation. So it's happening tomorrow, 11:30 to 12, the same room. Some of the known constraints here. Like any other new hardware development, there are some known constraints. Firstly, the number of hardware is going to be limited for a bit, and then there will be updates to system software and SDK as we get closer to the launch. So please be patient also if you don't hear back from us on technical queries and support immediately, because we are also learning as we're going. It's a new field. So yeah. So how can PlayStation help? First of all, we can provide you with requirement developer kits, hardware, and also ongoing support with developer support team, whom you can reach on DevNet via forums, as well as the private support tickets. We can also help you in getting your word out about the game, because we have a lot of events that we are part of. We can spread the word through blogs, Twitter, and also as soon as we have like a PlayStation VR storefront, we could discuss featuring there too. So if you're still not convinced, so we have our friendly staff waiting to show some awesome demos. So come experience some demos, and we are actually switching it up every day. So don't hesitate to come in twice. And if you have any questions, you can email me directly. I think I am on time, probably over time. So feel free to drop by our PlayStation booth or email me. I'd be more than happy to answer your questions. Thank you.